So like 70% of the emissions of the production of concrete come from not the burning or the fossil fuels to heat this up or anything else. It comes from a chemical reaction that's taking place.
It's worth noting that about 8% of all greenhouse gases come from concrete, and concrete is also the second most used substance on the planet next to water. And so I had no idea until I set up time for this podcast. And then also concrete is worse for the climate than flying. Aviation accounts for about 2.8% of total global emissions. So concrete really is an area clearly for innovation and because it has such a big impact. So Jonas, thank you for being here. You're my first guest ever to do 2 episodes, so you must be special. Handing it over to you, it'd be helpful to know how, you spent a bunch of time on this. I think we were hanging out once and you were telling me all these facts that I didn't know, but, maybe starting off a little bit about your background. And also, why don't you just give us a little background on concrete?
Well, I've been in software industry most of my life, and my career at least, and switched to real estate development a little less than 10 years ago. And, concrete doesn't sound like the most exciting topic to have on a podcast. But I found it really interesting in the fact that some of the things that you mentioned, like it's the second most consumed material in the world, second only to water, is something I think most people don't realize. And like you think about how much of our planet is covered in this stuff, a lot of roads, bridges, stadiums, buildings, dams, reactors. It covers a substantial portion of our planet. And this stuff produces a lot of greenhouse gases as a result of producing it. So if you can either find another material or improve the way the material's made, it has a huge impact, which is why I've found it really interesting. Personally, in our company, we've been trying to build with other materials than concrete, but it literally is a very sticky material. Cement, it has a lot of amazing properties. It's the reason that it's been used for so long. And so I think that it's worth spending some time talking about it because I think it's going to be here for a long time in the future. I don't think we're going to switch to another material. I think what rather is going to happen is that we're going to find smarter and more efficient ways to build with various versions of kind of cement. Whereas right now, it's been done the same way for the last couple 100 years, and it produces a reliable product, but it can be done very differently.
Because I think you were telling me it's the same chemistry that was kind of invented from the 1700s, I believe.
Yeah. If you've ever been to Rome, like the Romans, they were the first that kind of like used concrete at a big scale. And a lot of Rome is built out of concrete, and that was 2,000 years ago. So it's been around for a long time. And those buildings have been around for a long time. And so it's resilient. It insulates really well. I
can see that wall behind you is concrete.
Yeah, exactly. Not quite, but almost a quarter of concrete is made out of water. And if you live near a lake or an ocean, water has a big impact on temperature. It contains temperature really well. So it's a really good medium for insulation, which is it's strong, it's durable, lasts long, it's cheap. You can pour it and mix it and it dries into whatever shape that you want it to, and it insulates temperature really well. So it has a lot of great properties to it.
Yeah. And I think, it's kind of interesting to think about. Well, I was actually going to back up and say, maybe just walking us through, how does this come together? How does kind of maybe at a high level start to finish? So how does it end up on that wall, for example?
Yeah. Well, you start with limestone. So you have a limestone quarry where they are pulling up all this limestone out of the earth. And then you crush it, and then you put it through essentially a furnace. So the stuff has to be heated up to a really high temperature, around 1,300 degrees Celsius, in order for a chemical reaction to happen.
And I think that process also produces a lot of CO2, right? That heating process.
Yeah, that's right. So like you mentioned, 8% of all greenhouse gas emissions come from the production of just one little tiny component of concrete that represents 10% of the volume of concrete, which is cement. And cement is basically the glue that binds everything together with concrete. And this one little material, the glue, cement, is produced from predominantly limestone. And so you heat it up to this high temperature, and a chemical reaction happens where it releases carbon and oxygen, CO2, as part of a chemical off-gassing. So 70% of the emissions of the production of concrete come from not the burning or the fossil fuels to heat this up or anything else. It comes from a chemical reaction that's taking place for it to become the material that we know as cement. And so after it's gone through this long furnace process that heats it up and changes the chemical nature of this, Then it gets shipped out, and there are these big mega companies around the world that are huge companies, conglomerate companies, multi-billion-dollar enterprises that in a lot of ways have localized monopolies. They then sell that product to a much more kind of cottage industry, which is the concrete industry, where you see those cement trucks that go down the road and are mixing the cement in the back. Those are like the local supply chain, basically, for cement. They are buying the glue, the raw material of cement, and then locally they mix it with what's called aggregate, which is basically just like, it could be more of that construction debris. It could be rocks and sand and different things. And then it's mixed with water. And then you mix it together and it turns into that soupy liquid. And then it gets brought here and into this wall, where it can either come here in a few ways, but it can get cast in place and poured, or it can get poured into some form like a brick and then brought out to site and stacked. But it is essentially that mixing of glue with rocks and sand and water.
And I mean, that's really interesting and you think about this, when you go to different places, I'm always fascinated by architecture, and I always look at the buildings and the bricks and everything. And it's always very different. And I think it's part of that could be, as you're talking, I was thinking through this idea that concrete is kind of the glue that holds it together, but then all the other stuff that gets mixed in is more regional, right? And that's probably why when you travel a lot and you look at different buildings, that they look so different.
Yeah, right.
Yeah.
Like, the color of the material can be different. Exactly.